As a blockchain developer, when I write the smart contract for any project, I try to keep the data in raw format. I don't try to make multiple function and store in different variable. I try to keep the data in very clear form so I can utilize the data and I can design as per my requirement in the front end side. So this is the entire smart contract. We have all the feature and we have two mapping, but this particular contract keeps a lot of data about the staking, about the reward, and we have a pool system, we have a user information. So there is a lot of information, and this is the structure I have designed in the front end. So if I come back here in my constant file, here I'm simply fetching all the information. So if I come back in the index, and this is the entire function I have called contract data. You can see how beautifully I have designed. I'm really proud of myself that how beautifully it's look when you try to extract the data and design it as per your requirement. So let me give you a quick walkthrough that what exactly I have done. So first I have got my contract. This is the staking contract, and this is the token contract which user going to stake in the contract. Then we have simply checking for the ownership and the token address, because this one is important information we have to display in our application so that our investor can build the trust and they can see our contract on the explorer. Even we have verify our contract, so they can explore and they can check that what are the feature we have included, how the data is getting stored in the contract. So this information is very important. So first we have this notification, and this will keep all the information about the transaction, deposit and claim in a form of struct. So if you come back here, you can see this is the notification in which we have all of this 5 data: pool, amount, user, type of is going to have 3 stage. One is going to be a deposit, claim and reward. And here we have the timestamp when the transaction got executed, and here we have the array in which we're going to have the entire notification which user will create as a form of array. And that's what I'm trying to access here. You can see this will give me the raw data, and here I'm simply designing as per my requirement. I'm simply converting into a array. I can do that exactly the same thing in my smart contract. So for that I have to add 2 more function in the contract which is going to make my contract little happy, and it's going to cost me higher gas cost when it's come to deploying the contract. So I have taken this particular approach. I have keep the data as a raw format and I'm getting it as a raw form, and then I'm simply designing as per my and creating in a form of array. You can add multiple filter set. You can simply add take a simple input from the user and you can simply filter the data based on the address. You can do that, but we are getting it as a raw form, so we can simply play around with that. Once you will have this array, you can easily able to filter it based on the user address, based on the date, based on the amount, based on the price or token category. You can simply do that very easily once you will have this data in a raw array form. We got it. Then we have this pool, and this is the best part. I really like it. You can see that this is the variable which is going to keep the track that how many pools the user admin have created for staking the token, and that's what we are keeping track it. This variables looks very small, but this will allow us to access the entire data within the smart contract about the pool. So that's what we are doing here. So we are keeping this empty array which is going to keep all the pools which admin will create. Then we are simply calling this particular function pool count. This will give me the number that how many pools user have created. So when the admin will create one pool, it will go to 1. When it will create second pool, it will go to 2. When it will create third pool, is going to be 3. So it will going to keep the track of number of pools which user will create. Then we are simply converting into a number, and here we have built a for loop. The reason why I have taken this for loop approach here, because I have the data about the pool count, but I have couple of functions like pool info, user info, reward. All of these 3 functions require the index value, the pool ID. Then we can able to extract the data from this particular function. So if I come back to the contract, you can see here we have this function pending. Then we have the function for user, and we have this pool info which contain the information and it's required pool ID, and that's what we are passing. So when we're going to run the pool, is going to start with 0. As I told you that when you go to first pool, will have a 0 index, 0 ID, and that's what we are passing, and we are running the loop. This is the one way, or you can simply create a separate function and pass the data individually, and then you can simply extract the data from the contract. So that's the lengthy process, and that data is not going to be as efficient as you want. So we are getting all of this data in a single form. Then we have built this internal function because we have to get the details about the token. So here we are getting the deposit token and reward token, which you're going to stake, which you're going to allow user to stake and get the reward. So here we are calling 5 function, and it's going to give a lot of data. And then we are simply designing the data as per our requirement. So we are taking the address of the 2 token, the entire object of token A, the deposit token, and the entire object of reward token. So if I come back here, this is the function I have built, ERC20. And if I go to my constant, there you will find this is the internal function. This is the internal function which is going to simply return all of this detail about the token. So this is becomes really powerful. You don't need to allow user to ask manually. You are doing every single thing within the contract. You can simply do all of this in the smart contract, but again, it's going to cost you higher gas consumption when you go to deploy the contract. So you have to keep all those information in the contract, which is very important. You don't need to keep unnecessary data in the contract. So that's what exactly we are doing here. So we have built this internal function, and that's what we exactly calling here to get the information about the token. So here we have the two token detail. Then we are getting this total deposit, percentage, log days, and here we are simply formatting the user information like reward, log time, and last reward calculation. And all we are doing that after this loop, we are simply pushing to our empty array. So it will become a dynamic one. You can literally do all of this thing within the contract, but just imagine that if you really want to add all of this, your contract almost like 5 to 10x longer than what we have written here, which is not a good idea to build. So this is the approach you have to take it. Try to design your smart contract in a raw form. If I come back here, you can see that here I am doing a special thing. So what I'm doing, I'm trying to calculate all the token stake in all of the pool. For example, we have 3 pools in this particular project. So let me check how many pools we have created. So if I come back to the admin, and we have created 4 pools. Like we have created 4 pool in this particular smart contract, and that's what I'm doing. I'm building this dynamic logic. So it's going to automatically calculate total number of deposit in the contract in all of these 4 pools. So if I come back in the project, you can see if I go to the dashboard, there you will find that the total number of token stake in the entire project is this much, 165, and that's the calculation we are doing here. So sometimes it's also become very easy for you to be a little bit familiar with the JavaScript programming language. These methods are really powerful. It's such a lifesaver, because if you know all of this method, you're going to make your smart contract more efficient, and your application will be very fast, and you can able to design a perfect data structure. So that's the total deposit in our contract, which we are getting individually from individual pool. Then we are simply getting the details about the user. So when the user will connect their wallet, we are getting the information about the token in respect of the user, that what is the balance of the user in each one of these tokens. So that's what we are doing, and at the end we are simply passing all of these details. So contract owner, address, and this is the entire notification which will come as a form of array. We are simply calling this reverse method, so it will always display the latest notification. Then we have the reward token, deposit token, and this is the pool array. This is going to keep all the pool which user the admin have created in the contract. Then we have the total amount deposited in the contract, and here we have the contract balance. So as I told you that in the contract you have to provide some sort of surplus so the user can claim the reward. As you can see in the project, we have provided surplus of 87 token, and this is the total token stored by the users. So when they want to claim the reward, they can simply call it and they can claim the reward, and the fund will be deducted from here. If it's go into the minus, though, you as an admin, you have to simply provide the surplus. So then the contract will work perfectly. And that's what we are doing here. If I come back here in the index, you can see at the end, we are simply returning this entire object, all form of array. So if I come back here, if I simply console log out this to show you in the front end side, console log this and save it. If I do the inspect element, you can see we have all of this data in our console. Let's come back here and reload the page one more time, and you will see we have all of this data right up here. This is the token address, and if I open this one, in that you will have all the details. So this is the details about the token, and if you come back here you will find all of this details. So open this one, there is it. We have the contract address, owner address, contract token balance, deposit amount, and this is the entire notification as a form of array. And you can do the experiment on this. It's become very powerful when you design your smart contract in such a way. And here we have the pool, all the pool which you have created, and you can see in that you will have all of this data. This is the details about the deposit, this is the detail about the reward. All of this information you will have as terms of pool, which an individual pool. So that's the way you have to design the data structure in the front end side. Try to keep your smart contract raw, broad data, and you can simply extract the data, and you can design in such a way so you can simply utilize it and in your entire application. So this is the best strategy you have to implement. Try to keep your smart contract light. Don't try to include too many code, because the more code you will add, the more complication you're going to create, and there would be a higher chance of getting bugs in the contract. Because there is a lot of code, then definitely some sort of bugs will be there. So try to make your smart contract short and sweet. Keep the relevant data. Don't try to keep too many data in the contract. Just make it small and sweet. So that's the only thing from my end. If you have any question, any doubt, do let me in the comment section. I'll definitely try to help you in that. Have a wonderful day. Bye.